inshallah, will solve some problems related to synchronous machine. And let's start with problem number 3 in the textbook. It's similar to what we solved before regarding the open circuit and short circuit characteristics. And we are going to use it also to solve some regarding synchronous generator. So here the problem, Shabab, says the following tests are obtained. The following test data are obtained from three-phase 195 megavolt ampere, 15 kilovolt, 60 hertz star connected synchronous machine. تمام يا شباب؟ Screen is clear يا شباب or not? Screen is clear or not?
Clear, doctor.
Yes, clear.
Good. Okay. So these are the rated data, شباب, of the machine. 195 megavolt ampere. This is the apparent power. So we have, this is S rated. It's equal to 195 megavolt ampere. And 15 kilovolt. طبعا 15 kilovolt is the rated voltage. So this is rated volt. 60 hertz star connected synchronous machine. The open circuit test data are given like that. IF versus V line to line, which is the terminal voltage of the generator. تمام يا شباب. And as you can see, شباب, the point of rated volt is here. This is the point of rated volt, 15 kilovolt, and the corresponding field current is 750 ampere. And it's stated also that the short circuit test at 750, at the same current here, the current of the machine, the armature current, was 7000 ampere. So this is representing now the value of current at the same rated voltage and the same field current of a rated voltage. So we can say IA at that point here equals 7 kilo ampere. Right. Now it's required to calculate or first draw the open circuit characteristic, the short circuit characteristic, the air gap line, and the modified air gap line. يعني طبعا plotting these data شباب, يعني I will leave this for you. I will just show you the the plotted curve. I plotted here using MATLAB, for instance. I plotted the open circuit characteristic, this blue line, okay, and this line represents the modified air gap line, which passing at 0 and the value of rated voltage, okay, because we are going to use it in the problem. How we can draw the air gap line? We said before, air gap line is the tangent to the open circuit characteristic, so you can draw it like that. Okay, شباب. So this line here can represent the air gap line. Okay, type. And short circuit test, يعني it's linear regression. We don't need to plot it here, and it's not important in the problem. However, it's required, so you should also make another scale for current and plot the waveform of current. So this is regarding the drawing of characteristics. Number B, determine the unsaturated and saturated values of synchronous reactance in ohms and in per unit. طبعا شباب, this is in the textbook. In per unit, we did not discuss how to solve problems in per unit, so we are going to focus only on calculating based actual values. تمام? So يعني if you could find anything related in per unit in your textbook, يعني don't care about per unit calculation. Just you can calculate actual values and you can finally compare the results. So we need now to calculate the unsaturated and saturated values of synchronous reactance. طبعا here we neglected from the beginning. It stated that here the armature resistance is very small, so RA is neglected now. So we can consider شباب the reactance as impedance. Is it right? طيب مين يحل يا شباب؟ How we can get the value of synchronous reactance now for the saturated case؟ ها يا شباب مين يحل معايا؟
VT over I.
Exactly. So we can say now X is saturated equals VT. Which VT now؟ يعني from the characteristic we
Rated.
should calculate at rated. Exactly. تمام. So يا شباب it's rated volt V rated over the value of IA. Which value of IA? The value of IA which is corresponding to the same field current. So at 750 ampere field current, we said the current of armature is 7 kilo ampere. So we can say now V rated طبعا as phase يا شباب, so we can say it's 15,000 over square root of 3 divided by the value of armature current, which is 7,000 ampere here. So,
دكتور,
تفضل.
after you finish the calculation, can you repeat how we get the required current?
Again.
IA.
Okay, again, let's discuss how we can obtain this from the characteristic. Now, we said at open circuit characteristic here, for open circuit characteristic شباب, after plotting the curve, at this point, this is the rated value of volt, which is V rated 15 kilovolt. Okay, we should, after drawing the short circuit current, we'll draw also another curve like that for short circuit current. Okay, and the scale, you should make another scale for the current. Okay, and you will find that at the same value of field current, which was 750, you should get this value of armature current, which is already given by 7 kilo ampere. So this is now representing the armature current drawn from the supply. Any question, شباب? Is it clear?
Clear, Doctor.
Yes.
Okay. So now we can calculate the value of reactance. If you calculate it here, the value will be 1.24 ohms. So this is the value of XS saturated. طيب, what about the unsaturated يا شباب? How we can give the unsaturated value? طبعا we said for the unsaturated, this is the curve يا شباب. For unsaturated, how we can calculate the unsaturated value here? From curves. Firstly, which curve we should use to calculate the unsaturated XS? We have curves: open circuit characteristic, modified air gap line, and air gap line.
Air gap line.
Air gap line, this is right. So this is here, this is air gap line. Okay, this is the line of a air gap line. طب which point we should select يا شباب? How we can get the value of V in order to divide by the same value of current?
We draw vertical line at the same
vertical
current.
line at rated voltage at the same current. This is right. So we can just plot line, okay, at the same rated voltage. This line has to be vertically like that, and at the point of intersection, you should get the value of V and use it. If you use it like that, the value, the exact value from the curve should be around 18.75 kilovolt. يا شباب. Right. So from air gap line, we can say V of air gap line equals 18.75 kilo volt. طبعا in order to calculate X you have to use the phase value, so X is unsaturated equals 18.75 over square root of 3 طبعا kilo volt divided by the same value of A of current 7 kilo ampere, so the result will be 1.55. طبعا يا شباب the value of XS unsaturated has to be higher than the saturated one. طيب this is for part number B. This is regarding to part B. In part C here, find any question يا شباب please. If you have any question يعني ايه يعني you can ask يعني على طول no need for chatting messages.
Doctor, you divided the voltage by root of 3, so it's voltage per phase, right? So
Sure. If you would like to get the ohm or current, you have to use the phase value of volt. مظبوط؟
yeah.
Yeah, okay. طيب. So number C, find the field current. Do we have any relation يا شباب to calculate field current? Do we have any relation in our course and we use it to find field current of synchronous machine? We don't have any relation for field current. So if we need field current, you have to use curve, okay, and use the relation between or curve between EF and IF. Type. For now, if we would like to calculate the field current due to operation, now the machine will be connected to a load, which means it's going to be connected to infinite bus. Okay, so which line we should operate the machine now يا شباب? Is it going to work on open circuit characteristic or on air gap line or modified air gap line? Which line we should respect if the machine is connected to infinite bus? Modified air gap line. This is right. So here, find the field required if the synchronous machine is delivered 100 megavolt ampere at rated voltage at 0.8 leading power factor. So you have now the power factor and you know the value of apparent power. So simply you have a loading condition now يا شباب. All of time يا شباب, in order to calculate current and power factor, you have to find the loading condition. Okay, sorry, in order to calculate excitation voltage and the power angle, you have to find loading condition. Loading condition means S with power factor or power with power factor or the current itself given. All of these can be used to get the current. So again, in order to get EF at angle delta, to get these values, we need loading condition. Loading condition means S with power factor, S in order to get current, and power factor to get the angle of current, or P and power factor, or I and power factor, and all should be used to get finally IA as a magnitude at angle plus or minus cosine inverse power factor. In order to get this vector, تمام, you should have one of these three combinations. If you have one of these three combinations, you can easily calculate IA and use the equation of synchronous machine to get EF. Simply, here we have the value of S. So we have S equals 100 megavolt ampere, and the power factor also is given 0.8 leading. So simply, we can say now IA, the armature current, equals S, which is given S of the load, over the square root of 3 the line. تمام يا شباب؟ طبعا the machine is working as generator here يا شباب. تمام؟ So S is given as 100 megavolt ampere, so 100 mega to multiplied by 10 to power 6 over V line, which is 15 kilovolts, so 15 multiplied by 10 to power 3 multiplied by square root of 3. This is going to give you the amount of a absorbed current. The current here will be 3.849 kilo ampere. 3.849 kilo ampere. Type. After getting current, we have the angle to get the power factor. The angle of current from power factor. So we can say now EF equals V terminal plus JIAXS. طبعا substitute in the relation. So 15,000 over square root of 3 plus JXS, which is J 1.24. We have A already calculated, multiplied by the current. So 3.849 to power 3 at angle. Power factor is leading, so it's positive. Cosine inverse power factor angle, which is 0.8. Is it 0.8 or 0.85 here?
0.8 doctor.
0.8. Okay, this is right. So the value of EF here, شباب, will be 694.13 at certain angle. I didn't calculate the angle, you can get it. We need only to give the current of field, so we need to get the value of the excitation voltage. The required now is the absolute value. We got already the absolute value, and based on this absolute value, we should use our A curve to get the current. Which curve we should use? We agreed together the modified air gap line. We've plotted the curves, شباب, in line to line voltage magnitude. So firstly, we need to convert this one to line. So easily we can say EF line to line equals square root of 3 multiplied by 6941.3. Get this value and use the modified air gap line. So we can go to the modified air gap line here based on the A value. Okay, the value exactly, let's calculate it. 6941 multiplied by square root of 3, which is 12 kilovolt. So at 12 kilovolt, this is 12 kilovolt, we should use our modified air gap line and give the value of A of current, شباب. Okay, so the value of current should be in this point here, okay, which is almost 600 ampere. Type. So we can say now this is 12 kilovolt and using the curve, so IF is 600 ampere. This is from where, شباب? From modified air gap line. Why modified air gap line? Because the machine is connected to infinite bus. Type. Now we could get the value of field current. Then number D, find the voltage regulation of the synchronous generator for the load of part C, where the voltage regulation relation is given as, you know already the voltage regulation. It's no load voltage minus full load voltage over full load. Type. We have now the full load voltage, which is already the rated value, 15 kilovolt line to line. Now we need to get the no load voltage. But for part C, شباب, we agreed together when the generator is connected to infinite bus, we should work at this point here. تمام? This is the operating point at 12 kilovolt. We should extend this line like that here. Okay, so this is the operating point now. if the generator is disconnected from infinite bus at the same field current, what will be the magnitude of no load voltage? ها شباب. What is the meaning of no load voltage of generator? يعني if the generator is disconnected, so what will be the terminal voltage of the generator now?
We use the OCC.
We have to use open circuit characteristic. This is right. But what is the value of terminal voltage? Is it going to be the same as EMF or not?
Yes, doctor. Yes, doctor.
Yeah. Okay, so this is right. So now, in order to get the exact voltage when the machine will be disconnected from infinite bus, we should insert another line or draw another vertical line from the same 600 ampere and extend it to the A characteristic here to see the required voltage. يعني the required voltage is around 13.6 kilo volt. So based on that يا شباب, we can say now the voltage regulation we can say number C or sorry D, we need to calculate voltage regulation percent. We said when the machine is disconnected from infinite bus, this is going to make the machine working at open circuit characteristic. So this means that at the same field current of 600 ampere, the V open circuit equals we said يا شباب 13.6 or what؟ احنا قلنا تقريبا 13.6 is it right؟
Yes.
يعني تقريبا 13.6 طبعا يعني when you plot it to scale يعني easily get this value 13.6 kilovolt. So we can say now voltage regulation in percent equals V no load minus V full load over V full load. So we can say V no load is 13.6 minus V full load, which was 15 over 15. طبعا take care that this value here is line يا شباب, because we get it from the curve and all of the curve is plotted as line to line. So we should use here also the full load voltage as line to line. And from here يا شباب we can get the value of the no load voltage. So 13.6 minus 15 over 15 multiplied by 100 to be in percent. So this should be multiplied by 100%. So the result will be minus 9.3%. طبعا يعني why it's in negative يا شباب؟ why it's in negative in this case? Because as you can see, if we return back to the curve again, يعني now we're working here at that point, which is less than the rated voltage. Why? Because we are now in under excitation. صح يا شباب؟ This is now considered as under excitation because the field current is a small and the generator is leading. تمام. So this is right. So this is شباب problem number 1. Is there any question شباب in the calculation when we should use the modified air gap line, when we should use the air gap line? Everything is clear? طيب. Another problem in the textbook, problem number 8. Three-phase, 250 horsepower. So this is now the output rated power, because when we read here it's synchronous motor, so it's given here as output load. So this is the out rated. Okay. طبعا 2300 this is V rated. Okay. طبعا line to line. 60 hertz star connected non-salient means cylindrical يا شباب. Okay, so يعني we are working with the same type of motors. Non-salient rotor synchronous motor has a synchronous reactance of 11 ohm, so this is XS. When it draws 165.8 kilowatt, so this means which power شباب? Is it input or output?
input.
Input power, it draws. This is right, so this is input power now. Take care, electrical power for motor should be input power. Electrical power for generator should be output power. Type. So we have here B input, which is the electrical one, which we should use in our relations. Relation of power, EF V terminal over XS sine delta. This is electrical power. طبعا the power, this is the power input, and the power angle is 15 electrical degrees. So here B input is given and delta power angle is given. Neglect ohmic loss, so we can say RA equals 0. Now it's required to get the excitation voltage per phase. طبعا يا شباب يعني in problems we said in order to get excitation voltage, in order to get EF with its angle delta, you should look for loading condition. And we said loading condition, it can be S with power factor, P with power factor, or IA given with power factor. Do we have any of these?
Doctor, we have the power?
We have B. Do we have power factor? Power factor is not given. صح يا شباب؟
Yeah, doctor.
We have only power angle.
15 electric degree.
This is power angle, which is delta. So for this case يا شباب, we have part of vector here. يعني we have the absolute value of the vector. Or even the absolute value we cannot get. يعني the absolute value is S. تمام? We don't have even S. يعني in order to get S, we need the value of power factor. So even we don't have the magnitude of the vector here. And also here in this vector, we need the magnitude. However, the given is the angle. So in this case, شباب, we cannot use the equations. We can use either the relations of triangles, like the sinusoidal equation or cosine wave cosine equation, sine equation or cosine equation, in terms of the length of angle, length and angles of a triangle. This is one way. The other way is to solve graphically with phasor diagram, and you have to plot to scale in order to get values to scale. Yani let's solve the problem here by the two ways in order to recognize how we can use both of solutions. Now, let's start with the graphical solution, شباب. Graphical solution. طبعا graphical means you can use phasor diagram. But again, the data we have here, we have power angle equal 15. We have the amount of power. You know the magnitude of voltage. تمام؟ طيب. طبعا لا for this part يا شباب يعني we can get the power from the relation. Just a moment. يعني we have يعني this will be a problem for current only. يعني firstly start from the relation power equals EF V terminal over XS. طبعا this is multiplied by 3 sine delta. We have power, we have delta, we have V, so we can get EF. However, you cannot get current. So here firstly we can say EF equals P multiplied by 3 over multiplied by XS over V terminal sine delta. And here you can substitute easily and get the value of EF. So again, 3 multiplied by power 165.8 multiplied by a power 10 to power 3. Sorry? sorry. Three V terminal, which is given by 2300, so it's over square root of 3 multiplied by the sine delta, which is 15 degrees here. So we can get EF يا شباب. يعني EF here could be obtained using the power relation. The value of EF is 1768.86 volt. So this is the value of EF. Okay, the problem will be in the current. We cannot get the value of even current. We can get the value of current because EF is given now. يعني this is another issue. يعني here easily we can obtain it. طيب, I can give you another example how we can use the graphical solution. So here we could calculate the value of EF, and we have the angle. Draw the phasor, determine the line current and supply power factor. So simply now we have EF and we have the angle. So we can say from the relation of synchronous motor, we have EF equals V terminal plus, minus JXS multiplied by IA. So we can say now IA equals V terminal minus EF over JXS. So simply يا شباب, we have V terminal, which is 2300 over square root of 3 at angle 0 minus excitation voltage 1768.86 at angle of delta. طبعا delta شباب equals ايه؟ 15 or minus 15?
Minus 15.
Minus, because this is motor. Take care about this. Otherwise, you will assume that it's generator now, so everything will be wrong. طبعا over JXS, which is given as J11. So from here you can get the value of armature current.
Doctor,
تفضل.
for EF, there is 8 missing.
8.
XS is 8, right?
XS is 8 or 11? Sorry. لا 11. Okay, شباب. So we can get here the value of the armature current. And let's calculate it quickly. So the value of current شباب will be IA equals 54.128 at angle 39.7. Okay, شباب. So this means شباب the power factor is cosine 39.7, which is 0.76. طبعا leading يا شباب. Is it right? So this is number A, and B will determine the supply current and also the power A factor. Right, number D, if the mechanical load يا شباب is thrown off. Mechanical load is thrown off means the output power equals 0. Is it right? تمام يا شباب؟ output power equals 0. طيب, do we have copper loss here?
You said neglected.
Neglected. Is there any losses يا شباب exist here in our motor? And it's stated here, all losses become negligible. So if we have B out equals 0 and also B loss equals 0, so what will be the input power?
Uh, 100.
Here in part D يا شباب, it's stated that the mechanical load is
the
thrown
draw
off.
power. The draw power, دكتور.
Which drawn power now? يعني this drawn power was taken because there was a load.
Yes.
Now here, the mechanical load is thrown off, which means the machine is no load now. And all losses become negligible. So P input should be 0. This is right. Okay, شباب? So now P input equals 0. What is the value of delta, the power angle?
0.
It should be 0 as well. So delta here will be 0. So in this case, the required here to determine the new line current and supply power factor. طبعا we can now calculate the current and power factor based on the relations. So in part number D يا شباب, B out equals 0 and also B loss equal 0. So B input equals 0 and delta also equals 0. We need to calculate the current and power factor. Right. It's stated that the load is thrown off. Is it means the excitation voltage is different?
No, doctor.
So we should use the same value of excitation voltage. Is it right? Yani we did not change the field current. So we expect to have the same amount of excitation voltage. So we have here EF as a magnitude equals 1768.86. And we know that delta here equals 0. So simply we can say now IA equals V terminal minus EF over JXS. So it will be 2300 over square root of 3 at angle 0 minus 1768.6 at angle 0 over JXS, which is 11 ohms. From here, you can get the value of current IA. The vector will be IA equals 40 over 40 at 90 degrees. So it's 40 ampere at angle 90 degrees. So what it means now يا شباب, what is the power factor here? يا شباب,
0.
power factor is 0. 0 lagging or 0 leading?
0 leading.
Leading.
This is right. تمام, because the angle is plus 90. So this is now acts as synchronous condenser. صح يا شباب? So this is one of the special cases of synchronous machine operation. Type. In the same problem, it's required to draw the phasor diagram. طبعا you know the phasor diagram of no load at leading condition, يعني we will draw it. Then it's required to what percent should be the field current if be changed to minimize the line current. يعني ايه يا شباب? Now the field current should be changed in order to minimize the line current. So by how percent we should minimize the we should change the field current in order to reach to the minimum value of armature current. This is what the question mean. let's first draw the phasor diagram at in case of a 0 leading power factor. So this should be V terminal, and IA
AR
should be lead like that.
by 90.
تمام كده. And JIAXS will be in that direction. So minus JIAXS شباب will be in the other direction like that. So we should start here. This is JIAXS. And finally, EF should be the summation of these two vectors. So يعني, on the top here we can draw the value of the vector of EF like that. So this is now the phasor diagram. So this is V terminal, this is minus JIAXS, and this is EF, and this is here IA. So this is the case of synchronous condenser type. Number D يا شباب. Sorry, number 3. Now we need to minimize IA. طب we said before يا شباب, at case of no load or zero power, if we minimize the current, what will be the value of current? يعني power equals 0. When we change the excitation, which value will be current? طبعا we stated before, minimum current will appear at unity power factor. All of time, minimum current will appear at unity power factor. This is for constant power operation. And we already have power input equals 0, which means in order to have power equals 0 and power factor is unity, so the current has to be a 0. Is it right, شباب?
Yes, doctor.
And if we plot the V curve of this case, we can find that V curve will be like that. So this represents now the minimum current, IA equals 0. And this will represent at the same value if we plot the power factor. The power factor will be a maximum here. This is unity power factor. This is the relation of V curve, IA power factor versus IF. تمام يا شباب؟ So for this case يا شباب, we need to calculate the value of excitation, or not the value, for how much we should change the field current in order to get 0 voltage. طبعا we already يا شباب, we have the value of first case, and we can take the first case as reference and compare it with the second case. يعني we have EF1, which is calculated in the first part, and now we need to calculate the EF due to the minimum current. طب at minimum current, what will be the value of EF now يا شباب؟ ها شباب, EF equals what?
VT.
VT
VT, exactly,
is
because
no,
now there is no current, so it's 2300 over square root of 3. This is now the value of EF. So simply we can now say the reduction in EF, or the change in EF, will be EF in case 1 minus V terminal over, take the case 1 as reference, so over EF at case 1, and we can take it as absolute value. We need just change for by how much we should change the current. So now we can say EF in case 1, which is 17. How much is it? 1768. So 1768.86 minus 2300 over square root of 3 over 1768.86. and we need just changes. يعني when you calculate this change, it will be يعني 24.9%. So we need to change by 20 in field. تمام؟ يعني when you calculate the value of excitation, is it increased or decreased؟ يعني the power factor شباب was ايه in the beginning? The power factor was leading or lagging؟ يعني this value here 2000, this value here is 13 to 7.9. Okay, يعني now you have excitation voltage is greater than the terminal voltage. تمام. So this means that the excitation voltage in the second case reduced. Is it right? تمام. From 17 to 13. 1700 to 1300. So this means we have reduction. Is it right, شباب? So we reduce
Yes.
the voltage by 25% in order to convert from power factor leading to the case of a unity power factor. طيب. طب شباب يعني in case of we have any problem needed to be solved in graphical solution. يعني for any case. Let's solve this problem now by using phasor diagram in order to recognize how we can use phasor diagram to calculate anything. يعني if you miss one of the vectors magnitudes or angles in any problem, in order to solve the problem you can go to the graphical solution. يعني I would like to يعني describe it fastly with you. يعني discuss it also later إن شاء الله. So let's make the vector diagram. Now in the beginning we have the value of V terminal. So we can plot V terminal. Okay شباب. Then this is V terminal. Then we have the power angle. طبعا we should plot to scale يا شباب. Plot to scale means you have to make scale between the magnitude of voltage and the centimeters you plot. Okay. Then we can draw. يعني if you have for instance شباب يعني طب for this problem I will give you just modification for this problem. Instead of having the power is not given, and we can only يعني ايه consider the value of current. If we have current of for instance 50 amps, okay, and we don't have power factor, we have only 50 amps and XS is given 11 ohm XS, okay, and you have V terminal, you don't have EF, and required to get EF, and delta was given equals 15 degrees. How we can solve the problem in this case? يعني you have the magnitude of current without power factor, and you have terminal voltage and power angle. How we can proceed solving this problem يا شباب? Simply we should draw the curve, the phasor diagram, and start working graphically. يعني we have the power angle is 15. So we can make a line like that, but it's not a ram, sorry, and let's make it as just line. It's not the EF vector, like that, at 15 degrees. And this will be a locus for EF. Okay, so this is now locus, it's not the vector of EF. تمام. So يا شباب this is locus and this is here 15 degrees. Okay, طيب, with this is V terminal given. You have IAXS. IA equals 50, XS equal 11. So we can say vector IAXS as a magnitude is given 50 by 11. So 50 by 11 have 550 volt, okay? So you can convert this magnitude in centimeters and start using this lens and make the arc with the lens, okay? Yani just using your tools and plot this curve. So in this case, we can draw a line from this point like that to that point, and this now will represent the exact value of IAXS with angles. So this now will represent the length of EF. So you can make this lens with take this lens with roller and use your scale in order to get the exact value of voltage. Also, this angle, Shabab, if you use the triangle analysis, you will find that this angle is 90 plus phi. So if you measure this angle, you can get exactly the value of phi. Yeah, this is another solution. Inshallah, next class we'll try to get another example for this case. Right. Any questions, Shabab? Any question?